All right, so we are going to show you problem 4a, and the goal here is to show that for e equals the summation of n equals 0 to infinity of 1 over n factorial, that e minus Sn is in between 0 and 1 over n factorial times n. So the first thing we're going to do, we're going to represent the middle part of this inequality, e minus Sn. We're going to write it out as a summation. So we can represent it as 1 over n plus 1 factorial plus 1 over n plus 2 factorial plus 1 over n plus 3 factorial and so on, right? And from here, we're going to do a little bit of algebra. And our goal is to kind of set this up as a geometric series eventually. Because right now we don't have that. We have an arithmetic series. So the first step, we're going to actually factor out in step 2 here. We can factor out n factorial from each part, right? Because n plus 1 factorial is n plus 1 times n, right? Times n minus 1 times n minus 2. So we can factor out n factorial from all of these fractions here, all right? And we can see that happen in step 3. We take the 1 over n factorial out of all of them. Okay, and we're left with 1 over n plus 1 plus 1 over n plus 1 times n plus 2, and so on. Right. So moving on to step 4 is a pretty critical part to the proof. We're going to create an inequality here where the summation in step 3 is smaller than what we have in step 4, right? So we know that if we actually make a denominator smaller, it makes the fraction larger. So if we replace n plus 2 with n plus 1, we make the denominator smaller, and therefore this whole summation becomes larger if we're replacing all of these denominators with smaller amounts. Okay, so we can say that step 3 is smaller than the summation we have in step 4. And the reason we wanted to do that is because of what we see happen in step 5. We can write 1 over n plus 1 times n plus 1 as 1 over n plus 1 squared plus 1 over n plus 1 cubed and so on. And we now have a common ratio, or in other words, a geometric series, where the a value is 1 over n plus 1, and the r value is also 1 over n plus 1. So we see the a value here, and then we see the common ratio being multiplied by 1 over n plus 1 each time. All right, so since we have a geometric series, we can now represent that. We have 1 over n factorial times a over 1 minus r. Okay, so we're just simply going to substitute our value for a and r in and simplify. And once we do that, we simplify it down. So we have here, I'm going to multiply by n plus 1 over n plus 1. And we're going to get some things to cancel out. And we have 1 over n factorial times 1 over n, which if we look back up to the top of the proof, we could see is the goal that we're trying to prove, right? So we're trying to prove that e minus Sn is in between 0 and this value right here. And that's the end of the proof.